Welcome back! Now that you've explored how to use OpenAI's Agents SDK, let's turn our attention to CrewAI, another powerful framework designed to help you orchestrate multi-agent systems and control workflows. There are two main approaches you can take: crews and flows. Think of crews as your project manager, helping your agents work together and collaborate on processes. We will take a deeper dive into agents on the next slide. Processes are the methods in which agents complete their goal, from how tasks are assigned to the sequence of the workflow. Tasks are predefined actions that are achieved with designated tools and agents, keeping each agent's role and responsibilities organized. The key features of a CrewAI agent include adaptability, focus, and collaboration. Similar to agents built with OpenAI Agents SDK, CrewAI agents can respond to new contexts that appear in ongoing conversations. They are also able to focus on specific goals defined in a YAML file that will be imported into the main program where the agents are run. Other attributes that can be controlled include the agent's backstory, tools, and LLM model. Much like OpenAI Agents SDK, agents collaborate through a hierarchical or sequential process. Another approach is flows, which allows for more precision and control over your agents by defining the sequence of tasks. Other elements of flows include events, which are used to initiate workflow processes, and states, which ensure consistent, shared context throughout the flow. Examples of states include dictionaries and pydantic models that allow for data validation. Keep in mind that crews and flows are not mutually exclusive approaches, but we recommend starting off your agentic AI journey with one of the approaches to avoid conflicts in execution logic. Here's a comparison chart from the CrewAI documentation that outlines recommended approaches for common use cases. To support agents who rely on context to understand ongoing interactions, CrewAI uses different types of memory systems. Basic memory includes built-in short-term, long-term, and entity memory. It is suitable for most use cases, and we recommend using this approach for your project. User memory integrates Mem0, a memory layer used to create personalized AI interactions. External memory uses independent systems for specialized or cross-application memory sharing. Remember to store sensitive data such as API keys in environment variables before committing to keep them safe. CrewAI also equips agents with tools to help them achieve their goals. Like Agents SDK, CrewAI and LangChain provide built-in tools, which can be installed with pip install CrewAI tools. They help agents handle errors and cache results to avoid repeating work. You can create custom tools by either subclassing the base tool or using the tool decorator in the framework. An important thing to keep in mind is that an unnecessary amount of tools can overwhelm your agents and make your workflow harder to manage. Apart from tools, agents also need to access external sources of information, as you are designing them to help a nonprofit organization in real life. Knowledge can be in the form of text sources such as raw strings, TXT files and PDFs, or structured data like CSV files, Excel spreadsheets, and JSON documents. We're almost there. Here are the final steps you should follow before running your program. In your YAML configuration, make sure to equip your crew with tools and set up any tasks or processes. In your main script, specify inputs that will be passed to the LLM and kick off your crew workflow. To ensure that all dependencies are installed, use the CrewAI install command. Again, don't forget to store your sensitive information in a .env file for privacy. Finally, you're ready to run your agents with CrewAI Run. This command gives you real-time updates on what your agents are thinking and doing. Once the workflow is complete, you'll find a summary report in output/report.md, which includes your results, topic analysis, and suggestions for future improvements. Last but not least, we want to introduce you to N-shot learning, which helps overcome a lack of labeled data. Zero-shot prompting forces the model to rely entirely on pre-existing knowledge and the tokens in the prompt, as no examples are given in the raw input. On the other hand, few-shot prompting uses a few labeled examples to guide the LLM's responses. This approach is similar to one-shot testing, where a single example or prompt is provided instead of a few. For your assignment, you'll focus on one-shot learning to help you implement and test your agents effectively. This means that you are not required to facilitate a multi-turn conversation with your code. Instead, we encourage you to focus more on guardrails and security risks in your workflow. This wraps up Unit 2. From understanding agents and handoffs to configuring context, guardrails, and memory systems, you're now ready to build intelligent, collaborative agents that can tackle real-world challenges. Keep experimenting and get ready to put your guardrails to the test. We can't wait to see what you'll build.